July 17th. Alright, we have a problem from yesterday that we still haven't solved. What do we have today? Oh, damn. I should have known this. Zero index integer array contains 3 times n elements. You're allowed to remove any subsequence of elements of size exactly n from none. The remaining 2 times n elements will be divided into 2 equal parts. First n elements belonging to the first part and their sum is this. The next n belong to the second part and the sum is this. Difference in sums of the 2 parts is denoted as first minus second. For example, if this, return the minimum difference possible between the sums of the 2 parts after removing the n elements. So we have 3, 1, 2. After removing 1, if we're removing 3, that's negative 1. I mean, this is 1. I mean, this is 2. So yeah, we should remove 3. And this second one, 7, 9, 5, 8, 1, 3. So we remove n, and this is 6, so remove 2, right? So n equal to 2. So I remove 2, and basically I want the right hand side to be as big as possible and the left hand side to be as small as possible. And after I remove, I can do the sum. It feels like there should be a way to easily compute a sum, right? Something like a prefix sum might help, I'd imagine. The minimum difference. Guess some sort of DP, probably. I mean, or instead of thinking of removing 2, removing n, we can just say, I'll pick 2 times n, right? I'll pick 2 times n such that, or even simpler, I'll pick n, right? I'll pick n, and then after that I'll pick another n such that the difference is smallest, and we want to find the smallest. So if I need to pick n, this is the last spot I can pick, right? So if we divide this array into 2 parts, this is the left part, this is the right part, right? Then the question is, find the minimum subsequent sum in this and the maximum subsequent sum in this, right? So if we start from here, this is like the minimum, so this is 4. I need to find the minimum of this. How do you find the minimum? Oh, you find the smallest 2 numbers. So the smallest 2 numbers is 5 and 8. 5 and 7, so it's 12, right? Then you add one number. Right, you add one number. Let's say you I'm gonna say maybe you can sort it. Because the smallest 2 numbers, unless this is the largest two numbers, right? So let's say we have a heap on the right hand side and a heap on the left hand side. Actually, this is not right. My bad. I should redo this. N equal to, no, it's right. So I have 2, right? So let's say I have a max heap on here, and I have a min heap on here. So the min heap, I'll pop the first, pop the second, and I keep a record, right? So I keep a record of min is, index. It's index, right? Min 1 and min 2, ij, okay, ij. And here is, max 1, ab, max 2. Not sure if it's gonna work, but we're gonna try it out. So I have ij and a and b. So now I add 1, right? I add 1. Add 1 coming in. On this side is actually easier because you're adding new ones. So I just compare the new one to, if this is larger than the max, I just swap the max and I would put the max here. If this is not but larger than this, I will just swap there. Yes, this side is easier. This side is keep going to the left and then, I keep the maximum 2. Now this side is harder because is it? Can we do, because all we need to know is at a certain point, what is the maximum and what is the minimum on the left and on the right hand side, right? So in this question, basically what we want to know is at every spot. So at this spot, what's the minimum, right? What's the minimum? So this spot is 7, 9. This spot is 5, 7. And this spot is 5, 7, right? So this will go left to right. And now I can go right to left, which will find maximum, right? So we say in this, actually, we cannot do this spot. The first spot we can do is here. Right, so this spot is 1, 3. This spot is 8, 3. And this spot is maximum 8, 5, right? And that's it. So now what we want to do is to find the difference. So basically, if we go here, that's 7 plus 9 minus 5 minus 8. What's that? The 16 minus 13, that's a 3. We'll move on here. 5 plus 7, right? Minus 8 minus 3. This is 1. And move on to the next. It's 5 plus 7 minus 1 minus 3. That's 12 minus 4. That's 8. So the answer is this. Which means I just need to go once, save these, and then we go the other side. I don't even need to save both, right? I just need to save the sum, right? The max sum from right to left. I save it in an array, and then left to right, I'll find the min sum, and then let's try this. That seems reasonable. All right, let's see. This is what? 2163. We'll go right to left. still need a heap because n can be huge, right? What if n is gigantic? Yes, you do need a heap here. So you want to keep the sum, right? What is the heap? It actually should be a min heap. A min heap going from right to left. So at the top is the smallest. As long as your current is bigger than the top, we put it in. And then here is going to be a max heap, right? Left to right is going to be a max heap because at the top will be the maximum. So if the current is smaller than the maximum, you will swap. Oh, okay. That's actually go right to left and find the sum of the n smallest, no, n largest values, right? This requires a min heap such that when a new number, right, a new number is encountered, we compare the top of the min heap with the new number. If the new number is larger, right, than the top of the min heap, we pop the heap and add the number. Similarly, we go left to right and find the sum of no, it's not consecutive. It's a subsequence. I mean, we do change the wording a little bit. All right, so you are removing subsequence. Right, so when you remove subsequence and then it's continuous, but that's equivalent, right? That's equivalent to we picking subsequence. So these two are the same. So it doesn't really matter, right? If we pick, let's say we pick 9, right? We pick 8. So it's equivalent to say, instead of we delete 9 and 8, we can say I pick 7 and I pick 5. So that's like we're picking subsequence from the left and then we're picking the subsequence from the right. Yeah. Now subsequence is not consecutive. Subarray is consecutive. Subsequence is you can pick whatever you want, and as long as the order, the relative order is the same, that's fine. So we go left to right and find the sum of the n smallest values. This requires a max heap. Okay, so probably n log n, I think. All right, so what do? We need a heap. It's priority queue. I think for this, I can just do this, right? This is a min heap. And then what we need is a vector. Let's also do this. N equal to num size. All right, so this vector will save what? Save the sum, which is the max sum, right? Max sums from the right. Okay, now what we're gonna do is we're gonna go from right to left. Okay. Oopsie doozy. Right to left. So what we do is if the size of the heap is small, oh actually this is not n, my bad. We have to go divided by 3. That's n, and this I think it should be long. Yeah, this should be long. Yeah, that's all right. Yeah, subsequent subarray can be confusing. Alright, so we go right to left. So basically, if the min heap size has not reached n, actually this, yes, this is n. If its size has not reached n, and honestly, we don't go, oh my god, I think I have so many mistakes here. This has to be 3 times n, and this has to be larger or equal to, I believe is n, right? Because we can't go all the way to the left. So 0, 1, 2, yeah, this is the last one we can, so it's larger equal to n. Okay, and then, what do? We also need a sum, like a current sum. Long current sum. Okay. So basically we'll add everything until we hit, and then we will check. Right, so if size is smaller, if size is bigger, okay. How about this? How about this? We say if min heap dot size is equal to n. Alright? So which means the current one coming in, we have to do some comparison. How do we do the comparison? We'll check. And we say if nums I, if this value, because we are finding the maximum, right? So if this value is larger than min heap dot top, okay, that means we are going to replace it. So what we're going to do is the current sum need to minus equal to min heap dot top and min heap dot pop, and then min heap dot push nums I, right? So that's if it's already size n, and if it's smaller than the smallest, then we don't have to worry about it. So that's that. And then what? And then we have an else, right? Else, which means min heap size is smaller than n, then no question asked. We just go ahead and push the current nums, and we'll plus equal to nums I as well. Oh, I think do we have to do this? Not very sure, but just for the safety. Okay, so blah and a blah. So we are done, and then we need to check if min heap dot size is equal to n. That's a signal that we can put into max sums I. Right, so basically we say min heap size is 1, min heap size is 2, and that's when we can put the sum. So we'll say this will equal to the current sum. Okay, so that's one way. This is right to left and find all the max sums. And then we're gonna go the same thing but left to right. But before we do that, we need to do a priority queue again. And this time it's going to be a max heap. I actually forgot. Max heap. I think we have to do something like this. And std greater long. I believe that's how you do max heap. Okay, not 100% sure, but I think that's the way. Alright, so we have a max heap. We don't have to do the vector, but we do have to reset the current sum, and we also need a result. So res, I want a maximum on the res. Wait, hold on, we want a minimum on the res, which means this res shall be a big value. Can we do long max? Yeah, I think long max should be fine. Okay, now we're gonna go left to right and find all the mean sums. Okay, so I equal to 0, I smaller equal to, oh, where do we stop? 3 times n minus 1 minus 2 minus n. 3 times n minus n, that's 2 times n. Makes sense. Makes sense. So it's smaller than 2 times n. And then I plus plus. Okay? So we do the same thing. If max heap dot size is equal to n, then we check if nums I if nums I is smaller than max heap dot top, right? Which means the current number is smaller than the biggest number in the heap, so we need to swap. We need to swap it out. Say current sum minus equal to max heap dot top, and the max heap, I'll pop it, right? I'll pop it, and then max heap dot push. Let's do this. Long nums I. Oof. Okay. So that's that, and we have the else again. Else is max heap dot push. Oh, I think I forgot a long. Hold on, I think I forgot here. Oh, no, not here. Here. I forgot a long. Probably I don't need it. Actually, I think probably I don't need it because when you push, it's a long. It will do the conversion for you. But I have been bitten before. You know, C++ is not the most forgiving. Okay, so we done all this, and then we do the same thing. The size is equal to n. Then we can say res equal to minimum res, and then we say current sum minus what? Minus. Oh, I see another issue. Oh, jeez. Hold on, I think this is a problem. This should be 3 times n. Wait, would I go out of bounds 3 times? Should be fine. I don't think it will run out of memory. So current sum minus the max sums of what? So we are, I is here, right? I is here, and what we check the next one, so I plus 1. I plus 1. Is that right? Yes, I plus 1. So the current sum minus max sums I plus 1, and then blah blah blah, we try to do everything, and at the end we'll return the result. Alright, moment of truth. Let's check. Oh my goodness. Oh wow, both are wrong. Big time. Alright, no worry. Let's debug this. I think the idea is right, but maybe there's something wrong in the implementation. Alright, so what is this? 312. And this is what? This is what's the name? Minimum difference. Nums. Okay, so I will. What's this one? 17. Build it. Let's put the breakpoint here. All right, let's debug this baby. Alright, so we have priority queue n equal to 1. That is correct. I believe it's F2, right? We go down. Yeah. So current sum is 0 is right. So that's 3 minus 1 is 2. And n is 1. So 2 and 1. Yes. So main heap size, no. current sum plus, hold on, what's the nums? Let's show nums. So it should be 2, right? Current sum is 2. Size is equal to 1, yes. So max sums is equal to 2. Good. Next one. Main heap size is 1, yes. So this is larger than nums I is 1. Larger than the other main heap top? No. The answer is no. I get out, and it's 1. So that is the same. So that's 2 and 2. Good. Done. Max heap. Result. So start from 0 and 0, 1, 2, start from 2. Yeah, that's fine. So the first one is not. So I put max heap in. Current sum is going to be 3. And this is equal to yes. So 3 minus I plus 1. So this will give us 1. Right? Okay, rest is 1. Next, nums I is smaller, yes. Current sum minus equal to. So that will get the current sum to 0. Dot pop. Oh, you forgot to. Oh, I know. I see the problem. I forgot to update current sum. Current sum the plus equal to all right, I want to try without this. I think it will be converted. I think it will be converted. And here current sum plus equal to nums I. And this is going to be, all right, let's try it again. 52. All right, let's try it again. All right, the first one is right. The second one is still wrong. That's all right. Let's debug the second baby. Let's see. Let's do this. Okay, we'll build. Okay. So we start with 3. All right, current sum is 3, but it's not equal to n because n equal to 2, so I skip. That's good. Second one, so that will be 4. All right, current sum is 4, and I'll put 4 in there. That's good. Next one is 8. 8 is larger, so current sum need to minus the top because it's main heap, so minus 1. 4 minus 1 should be 3. Huh. I think I got the heap wrong. What's prior is this? Is priority queue min or max heap? Ah, Jesus. By default is a max heap. Oh shoot. That's alright. That's alright. So basically I need to put this one here. And that's the main heap. And I'll put this one here, and this is gonna be the max heap. Yep, I got a heap wrong. So default is max heap. Default is max heap. In Python, default is main heap. I don't understand why the two, why they do it differently. All right, I'm gonna submit. So I think the logic is right. I think the runtime is good. The only worry is overflow. So let's hope there's no overflow. Huh. See, this is something I'm not sure if it's, if I'm wrong. Oh my God, we passed 109. We passed 109. What the hell is this? Jesus. Are they all the same? I don't know. There could be. I don't think it's overflow. I mean, if you want to check, we can check. Just to make sure. How about this? We do. Yeah, we just want to make sure. So we do long num. Okay, we do long num. Just to see if the reason is overflow. But that actually also makes things maybe easier. Alright, because I set this up so everybody can use the same thing. Okay, and then we'll do the same down there. You know, just try. If you give me same answer, then that's definitely not overflow. Yeah, it's not overflow. It's just wrong. I am not sure. We passed 109 test cases and we failed on the last one. Like, what the hell? How? Oh, I hate this. I hate this so much. I'm out of ideas. I don't know. It cannot overflow. No idea. I mean, we can. It doesn't make any sense, right? Oh, that's probably not even a multiple of 3. Oh, this is right, but how can I even create a test case for this. Like, dude, how am I even supposed to create a test case for this too? Don't know. I remember seeing a lot of things like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, I need 4 more, right? 1, 2, 3, 4, 5, 6. I need 6 more. I don't know, I'm just trying to recreate. That is not bad. We recreate a scenario. Alright, let me make it even simpler. So we delete 2. Yeah, let's do 3. 3 of this. And then we do 3 of this. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, let's try this one. Hopefully this is also failed, then we can debug this. Ah, jeez. Shoot. So I have to go back to the original. Okay, so this failed. Interesting. Alright, how about we make the value a little bit smaller? It shall still work, right? It shall still fail. Yep, it still failed. That's good. That's good. 110, 110, 110. So that's 6. 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if I want to reduce, if I say I remove 2 of this, so right now is, wait, how many is right now? I just counted, man. It's 5, 6 is 11, and this is 18. So we have 18. Okay, 18 is 3 times 6. How about we go to 15? So go to 15. We need to remove 3. So I don't know. Maybe we can remove, I don't know, 2 of this and then 1 of this. Damn it. Okay, let's just deal with this. It's wasted too much time if we really try. So, okay, 10. So we have 3, 4, 5. Or 5, 10. And 1, 2, 3. And then we have 1, 2, 3, 4, 5, 6, 7. Okay, that's what we have. So n is equal to 6, right? So basically we have, wait, what's the answer? Expected 18, I'm giving 10. So I'm actually giving something smaller. Huh. So I have 1, 2, 3, 4, 5, 6. So this will be the first one. Okay. This will be the first one. So we have 6. And then here, 6. And then here, we can have a 10. Right? So minus 1 is 5. So this is 15. And then we come here. This basically is still 15. Come here. minus 1. So we have 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So this is the end. Sorry, this is a 10, so this will be minus 1 is 14. So this is 24. This is still 24. And this is 24 minus 1, 33. Right, so basically it's 3 10 and 3 1s. Makes sense, right? Makes sense. And you can only get it when you hit here. So now we go left to right. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So that's 51. Right? So you can already do 51 minus 33. So rest 51 minus 33. That is already 18. That is 18. Right? And then you move on to the next. It's a 10. So that's still 51. Right, this is still 51 because it's a 10. I want to find a minimum. Now you come here. That is going to be 42. So here is 42. So now you have 42 minus 24. This is 18. 18 again. Next is a 10, so that's still 42. So this is a 32 plus 1. This is a 33, right? This is the minus 10 plus 1. So now it's 33 minus 15. That is unsurprising, still 18. And the next one is going to be 33 again. Next is 24. This should be 24. 24 minus 6 is still surprising 18. Everything looks fine. And that should be it. It should stop. Right? It should stop. Where does 10 come from? Okay. That's fine. We established that the logic is right, but maybe there's some issue in the implementation. So let's try with this. All right. We have the ground truth. We just need to see if it's right. Yeah, so we're gonna start with 1. Current sum is 1. Current sum is 2, 3, 4, 5, 6. Put in 6. Okay, so 1, 2, 3, 4, 5, 6. That's good. Next is 6. 6, 6, 15, 15. 15, 15. Next 24, 24, and 33. Okay, 24, 24, 33, and then we shall end. Yep, this is good. This is good. Now we go max heap. So we start from this. So what we're waiting for shall be 51, right? That's the first one. So 10, 20, 30, 40, 50. And then next one, 51. Yep, so 51 minus, that should give us the result. Hold a second. Hold a second. Oh, I see why it's wrong. Dude, how does this pass all the others? How does this pass all the others? We have a typo. Jesus. Unbelievable. Again, like, how do we pass all the others? I don't understand. Yep. Double check with this. Yep. That shall do it. There we go. Not bad. Not bad, especially considering yesterday was pretty poor performance. Yesterday performance was pretty poor, so today kind of a redemption. 90 milliseconds. 91. Yeah, that was a stupid mistake. I don't know why I put it as a main heap. What is even weird is like this mistake did not cause any error. Yeah, so stupid. Alright, let's check the editorial. Priority queue, exactly. And yep, we have, well, they start with max heap going from left to right. We start from main heap going from right to left. It's the same thing. And then, okay, they first do the n, which is fine. And then they do this yes, which is fine. Part 2 is main heap. They go from right to left. And then every time they do the answer. Yep, exactly the same. Exactly the same. Yeah, I think it's not that hard. And honestly, I think this one is harder. That's just my opinion. In general, I think DP is always harder. Alright, that'll be it. I